So ER diagrams, ER modeling, entity relationship diagrams, entity relationship modeling. I didn't really talk about this. I realized I did chapter 5 slides. I'm like, well, I think it's because I've talked about this so much just in the course of describing things going on in the Access labs and stuff. I didn't realize I didn't give a sort of semi-formal lecture on it. And it's one of my favorite. It's between this and the stuff on normalization that you'll get in the second half of the semester. Those are the things that I like to talk about the most. It's more the easiest to talk about for me. So I hope you don't mind the slides. Slides just guide my thinking. I could probably just do without the slides and riff, but they're also good to use as demonstrations of things. I'll probably pick out some of the figures too. I've got a folder full of figures from the book, and I'll just pick out the chapter 4 figures and use them as examples sometimes too. But anyway, what this is going to be about. So I did chapter 5 first, so I'm going to put this one up, and then the second one, you need to watch both of them before the midterm, because you really want to watch 5, because I think I go over new stuff. I've kind of covered this stuff already in chapter 4, but I think it would be good also. Just make sure you watch both, and it's better if you watch them in order if you watch both. So order being not the order I made them in, but the chapter order. Okay, well, so let me, here, hold on. All right, I was trying to get the figures ready in the meantime, and so I could just not even say anything to you, and you wouldn't know, because I would if I edited it correctly, but I just have to imagine that I'm talking to a class, or I can't get through this, so that's why I'm like, hold on a second, even though it doesn't matter to you. You wouldn't know otherwise. Anyway, so let's look and see. So the main characteristics of entity relationship components, that's just like what do the things in the diagram mean. And you know this stuff a lot already, but I'm just going to review it. So let's just go through it. So yeah, the main components are entities, attributes, and relationships. So entities are rectangles with a singular noun in the middle, not a plural noun. Usually all caps in the diagram, but that could vary a little bit. Attributes are things about the entity. These are the entities are the tuples, the individual pieces of a tuple, all the different fields you put together to make a tuple, which is to make an entity. Take all those things together, and that's what the individual things are attributes. So attributes are just characteristics, traits of an entity. So like the first name, last name for a person, right? It's first name, last name, sex, date of birth. These are all attributes. Relationships usually take the form, they're inspired by the business rules. So relationships tell you here's the characteristics of a relationship. I'll just list them briefly. There's something called degree, there's something called cardinality, and there's something called participation. Those are my words for it. There are also other people's words. There could be some variations on those terms in between, but I'll describe what I mean for each of those three. There could be other aspects of relationships. There's weak and strong and stuff like that. We'll go over all that. But the main thing in my mind, number one, is cardinality. That's the biggest thing that you notice about a relationship first. And again, we'll see that here in a second. Then there's degree. That seems to be kind of intuitive, but like calling it a certain name doesn't necessarily make sense. And then participation, I would put participation before degree. In a way, degree is more basic, but it's sort of also just taken for granted. But the cardinality and the participation might be things you want to talk about a little bit. All right. Next slide. Okay. It's so annoying. Now I don't know how to go back. There we go. So what is an entity? It's just like a noun, a person, place, thing. I think you guys know what they're patient, doctor, movie actor, employee, student, teacher, course, just these nouns. That's what an entity is. It corresponds to a whole table. In the entity relationship model corresponds to a table, not a row in a relational. Yeah, so the ERM, that's a bad initialization. I wouldn't use that. I would just spell it out because it kind of made it confusing. But they're saying that in the entity relationship model, an entity corresponds to a table, not a row in a table, but a table. The row corresponds to a record, which is an individual instance of an entity. So not doctor as a concept, but Dr. Zhivago as an individual entity, instance of a doctor would be the row or the record. Chin and crow's foot, those are two different styles of ERDs. We'll talk about the difference between the two. They're pretty much interchangeable. Like, you could pick one or the other and just do it and it'd be fine. It doesn't matter which one you pick. I feel like the crow's foot's a little easier to work with, but the chin's also valuable to know because there's some symbols in it that make sense in other places in modeling more easily. Chin was first. Chin came up with it, and then crow. I don't know who came up with crow's foot, but you can use them. Some people use a mixture of them. It gets confusing sometimes, but I'll show you the difference. And then UML, Uniform Modeling Language. If I remember, that's what it stands for. It's not just for databases. It's used in programming and other stuff too. So it's meant to be a universal, might be universal modeling language actually. It's meant to be a universal way of describing all kinds of different systems, not just databases. So the first two are specifically for databases, relational in particular. UML is kind of like overlapping. If you're working with an object-oriented language and a database at the same time, it's sometimes useful to do everything as UML. But I'm when I'm talking about databases, I'm partial to crow's foot and the actual ones that are created specifically for databases. All right, attributes. So these things, I guess these things are important to talk about now. I feel like when you see the diagrams, all this stuff sort of makes sense. But a required attribute, that would correspond to a field that can't be null in a database. And optional could be null. Domains, just everything all the values you can have for the attribute. So for a date of birth attribute, you would have to have a date, right? Probably a month, a day, and a year. And you might have a further restriction on that and make it like from 81 forward or something, unless you're doing historical figures. You might just make it, if you're talking about living people, you could make it starting with just to be safe. I think 1900's safe actually, because I don't think there might be a few people that are more than 121 years old right now, so maybe make it 1800s. But that's going to be decisions you make in the design. But domain's just the possible value. Let's see, another would be like a numbers. Maybe you need an integer, and you start with 1 for whatever it is. What would be a good example? So like if it were a product, like in your inventory for a store, you could have quantity on hand, and that would be 0 or above, 0, 1, 2, 3, 4, 5. You might allow negative quantities if you're accounting for shrinkage, where things go missing or stolen or whatever. So those are choices you have to make. An identifier is like a primary key. We talked about that before. So yeah, they're showing. I'm going to just go on from here because I don't think you need to know. I'll talk about this real briefly. A single valued attribute only has a single value, multi-valued attribute. So an example here of this would be you would have maybe you have an attribute called address. That could be a multi-valued attribute. And the thing is, attributes attached to entities or other attributes. So you could have address, and then you could break that down into house number, street, city, state, zip. Break that down. That would be multi-valued, I guess. All right, so this is showing you a real basic example of the difference between chin model and crow's foot. So for one entity and its attributes, this is what it looks like in the chin, the original chin model. It's a rectangle. The entity is the rectangle. Capital, singular noun, student. So this is going to be this will eventually become a table of students in a database. And then these are the fields or the attributes of the student. So a student has a first and last name, an initial, probably a middle initial, an email, and a phone number. And you see that the attributes are indicated by ovals attached by lines to the rectangle. Crow's foot, this is showing you the exact same thing. And it's really kind of like your flavor. Like, which one would you rather pick? There's no particular reason that I can think of off the top of my head. There's probably some reasons I'm not foreseeing, but like in general, if you're like going to whip up a model of a database after you get the business rules and stuff, you could just sort of flip a coin and pick either one of these. You can see the crow's foot's a little bit more neat, I think. This can get messy over here. So whereas you have a rectangle for the entity, you have just you have a box, you still have a rectangle, but the name of the entity is in a bar at the top, and then the attributes are listed inside the field in the middle there. That's crow's foot. And this is showing you like a more some more detail. Like, okay, you can see the underline here. This is how you would indicate that it's an identifying attribute, I guess is what they would call it, but I just think of it as the primary key, because you can see it's the primary key over here, PK. So you put a line under the name of the attribute. Multi-valued attribute in an entity. I'm not sure what it's saying here. Maybe they're talking about car color, because a car can have more than one color. So this notation doesn't come up a whole lot, so don't worry about it. But I think that's what it's saying, because the car year is going to be 1 year. It's the year it was made, right? 2006 Miata. The model code would be MX5. Yeah. And then the car. This is a primary key, right? The vehicle identification number. So that's unique. But the car color could be a two-tone kind of thing, right? Or 3 colors. That's why it's multi-valued. All right. Requires, I don't know why they're going on about it. It's not important. Don't worry about it. A derived attribute, though, you should know what this is. Age, for example. I think they usually put dotted line under the name if it's a derived attribute, or maybe it's derived. It's dotted oval. We'll have to see if they have it on a slide. But what the thing is, you need to know what it means. A derived attribute can be figured out from another attribute. So it won't necessarily even be in the final table at the end. So age is one of these things. If you have the date of birth and you know what today is, you can derive the age. So age would be something you could derive. They've got other names for it. Calculate. You can calculate the age, right? So let's see if they show that here. Car VIN, car year, car top color. This is just where they break down the multi-value attribute into 3 attributes. I don't know why. They just talk. See if they talk about derived attribute here. Okay, here we go. The way they've done it with the CHIM model is they do a dotted line. So it's neither one of the things I said. I could swear that in my CHIM models I've seen before, you would have dotted oval around age to indicate that it's a derived attribute. But age can be derived from an IMP DOB, date of birth. All right. And you've worked with derived attributes in Access, so you kind of know what the end result of this will be. Keep in mind, what we're talking about right now is the stage you've gathered the business rules, you figured out like how the entities, what they are, what their attributes are, how the entities relate to each other, and now you're drawing like a picture of it. Then you take this picture and you implement it in an actual database management system like Access, for example. So it's a process where you gather requirements and information, make a plan. The plan, this picture right here, this model, this logical model is part of the picture, and then you take this and you implement it in an actual database management system. So we're at that stage right before implementation. All right, so don't even worry about this. I guess it's just showing you, like, if you actually store like an age, then it'd be less processing power to derive it, but at the same time you would have to like figure out some way to figure out the age. You'd have to update it every time they had a birthday. So I don't know what they're trying to say here, but that's just for age too. There could be other derived attribute, like the average. That would not be a column in the table though. I'm trying to think of something else that you would calculate. If I think of an example, I'll let you know, but don't worry too much about this. If you know the age and date of birth example, as far as derived attributes go, you're fine. All right, so relationships, connectivity, cardinality. Let's see what they mean by connectivity and cardinality. So association between entities that always operate in both directions. Participants, entities that participate in a relationship. Connectivity describes the relationship classification. So to me, that's cardinality, but maybe it's a little bit, yeah, I guess cardinality is a more specific version of connectivity. So the classifications 1-to-1, 1-to-many, or many-to-many. Those are the those are the classifications. You're pretty much not going to have anything besides that. So an example of one-to-one would be that whole uh, employee manages department that we saw, that you will see in chapter 5 if you're watching these in order. That's a so you have a department. It's managed by one employee, and an employee will manage zero, because not every employee gets to be a manager, right? Zero or one department. That's a one-to-one relationship. One to many, one doctor treats many patients. And many to many, an actor acts in many movies, and a movie has many actors in it. That's many to many. Cardinality, minimum and maximum number of entities. I usually actually use cardinality to sort of mean this, and you'll find other people do too. But cardinality could be something like you have to have at least 5 and at most 10, instead of having one and one here, or instead of having many to many here. Instead of having one to many here, you might have 1:5, 10. At least 5, no more than 10. That's what it's kind of saying. All right. Okay, so this is I don't call it this, but so existence, dependence, and independence. The entity exists in the database only when it's associated with another related. So this will be a case of like an employee and a literal dependent, like a wife or husband or children that are dependents of that employee. That would be what they're talking about here. In that case, those other entities, like dependent, would usually be a weak entity, and it would have a strong relationship to the main one. Like, so a dependent of an employee has a strong relationship with the employee, and the dependent's a weak entity because it would not exist without the employee entity in there. The strong entities can kind of stand on their own, and no other entities really determine whether they exist in the database or not. And that's what these are. So entity exists apart from all its related entities. They can be related to them, but it also exists without them. So you could have maybe a doctor who doesn't have any patients, for example, even though a doctor could have some patients. So his existence doesn't depend on the fact that any particular patient exists or not. So that's a strong entity. All right. So a weak relationship. Make sure you know this for the test. A primary key of the related entity does not contain a primary key component of the parent entity, and is signified by dashed line. So in a case here, I had to stop because this gets flipped in my brain all the time. So make sure it doesn't happen to you. Like, go over it like a billion times, because I thought like in my next video I said it wrong, but I didn't. So it's a weak relationship. A weak relationship. The primary key of the parent. So the example of the doctor and the patient. If you look at the patient primary key, most of the time these are going to be two strong entities with a weak relationship, if you're going to model them the way I would model them. So if you look at the doctor table, the doctor entity, he'll have a doctor ID. That's its primary key. And if you look at the patient table, the patient will have a PID, patient ID. The patient's ID will not have the doctor ID in it. So you won't identify patient Jeff Jones, whose doctor is Dr. Zhivago. Let's say Dr. Zhivago is 101. That's his doctor ID. And Jones is, as long as, did I say Jeff Jones? As long as his patient ID is not something like 101-001, because he's the first patient of, I even shouldn't say dash, because it would be two separate fields. So as long as his primary key is not a combination of doctor ID, because Dr. Zhivago is his doctor, plus say something like sub ID, like 001, patient 1. As long as that's not the case, this is a weak relationship. So normally the patient and the patient ID and the doctor ID won't have any relation to each other. The way the tables are related is that there will be a foreign key, which will be like assigned doctor in charge, whatever. Then that primary key of the doctor will appear as a foreign key in the patient table, but the doctor's ID will not be part of the patient's primary key. If that's the case, then they have a strong relationship, which is also called an identifying relationship. So that would be the case where I go back to the example of the employee and the dependent. If the dependent's primary key is something like employee ID plus dependent number, something like that. So it would be employee number 637. That's the employee's ID. If the dependent's ID, it would be better if I had a picture of this, and maybe there'll be some here in a minute. But if the dependent's ID was first the employee ID and then another column, which is like dependent number 1, number 2, number 3, if that's how you made the primary key of the dependent, then that would be a strong relationship. All right. And that's signified with a solid line versus a dashed line. And what you're going to find is like they're not always consistent about this dashed and the solid lines. So we'll see some examples here in a minute. Okay, that's enough of that. So here's weak entities. So in the CHIM model, let's look at what we got here. CHIM model, again, they didn't show you a basic CHIM model before doing this weak stuff and everything, but that's fine. So the CHIM model, the way you show the entities is with a rectangle and the name of the entity in the box, a single, uppercase, singular, not plural, noun. So employee. He could also have some attributes. They would normally be in bubbles around here, ovals. The attributes would be, but they just kind of list them under here for both of these, so that's fine. But if you did show them in a Venn diagram, they should be bubbles attached with lines. Then a relationship is going to be a line from one to the other with a diamond. The diamond is how you show a rhombus. A diamond is how you show a relationship. And inside you'll have a verb. It could be just an active verb like has, or it could be active and passive. So it would be has / is had by, I guess. There's different, but it'll have some kind of verb, whether it's active or passive. And then you have the cardinality. I guess this is the connectivity. So this is one employee has many dependents, possibly. This O right here means that it's optional. He might not have any dependents. It might just be him. He's single, never married, no children, no dependents. So that's why it's showing it's optional. And then the double lines means it's a weak entity. The dependent's a weak entity. And here's what I was talking about. If this primary key is part of the primary key of the other thing, then it's a strong relationship and probably a weak entity. So the primary key of the dependent in this picture is the imp num. The primary key from this table is part of the primary key of this one. So you take this imp num and add a dep num to it, and that's the primary key. Those two things together make one primary key. Think of the black things as all one thing put together. They're two different columns, two different fields, but the values in them compose one primary key. And if this thing in another table is part of the thing here, then you have a strong relationship between these two things. And it's just showing how it would look in the crow's foot, so you can see them compared to each other. So you got the attributes down here, the primary keys here, and this is showing that the primary key of the dependent is the foreign key from this table. That's what the FK1 means, plus just another field you make up. All right. A weak entity and a strong relationship. That's usually how it works. It's usually, if you got a weak entity, then you have a strong relationship, because that relationship between like an employee and a dependent, think about it this way. That's a strong relationship. That's family probably, right? Think of it that way if that helps. So the strong wage earner is going to protect the weak entity in their strong relationship. They have a strong family bond, and he protects the weaker people in his family by going to work and making money. I don't know if that helps. All right, so Venn diagram. Okay, so this is just showing you, okay, this is participation. Optional participation is symbolized by a circle. You can think of this as the letter O for optional, or 0 for 0 or more is how my brain wants to do it, but it looks more like an O than a 0. But anyway, so here's this. We'll talk about this in the next video, where we talk about more advanced. So this is the basics, and we're talking about more advanced in video for chapter 5. But we talk about this relationship. This is typical in most like universities, schools, whatever. You'll have the abstract notion of a course like CITC 1303. This is what you see in the course catalog. And then you have sections. This is called class here. People use these terms, and I say this in the other video too, so you're going to hear this twice, but people use these terms interchangeably, but there is a shade of meaning usually if you choose to make the distinction between the two. Like, have you had that class yet? Oh yeah, I had 1303. I've had that class. But really what you mean is the course. The class is the individual instance of that. You can call it a section, I guess. Strictly speaking, section doesn't always work because, like, at a bigger college, like I know, like a UT, you could take there are several different sections for one course, but it could be in the same class. In other words, you'd have the same meeting time, same professor, but the students, there'd be like 200 students. They would be in different sections inside that one class because maybe they would have different lab times or something. So section doesn't always mean class, but for our purposes, I think we can think of it that way. So a class you can think of as a section of a course. That's the way it usually is at Pell Sippy, I think. But really the meaning of a class is a group of people who come together to study the same course at the same time in the same place. That's a class. It's that body of people. It's kind of like a church is really the people. You've heard that if you've gone to church. It's not the building, it's the people. That's what a class is. The course is the description and the things you learn and all that kind of stuff and how many credits. The class is the body of people who are learning that course. Each time you have for each time you assemble that group of people, that's a different class. So this is what this is saying, is that CITC 1303 generates 0 or more classes. The case where you would say optional, the instance where that would happen depends on your meaning. I could say maybe, for instance, I sat down and I created a new course, and let's say it's mobile application. It's existed before, actually. It's in the book, but it's not been taught in a while. Let's say it's never existed. Mobile application development. That's a new course. It's in the course catalog. It's been approved, but we've never had people come together and register and sit in the same classroom and follow that course before. That's why you would say it's optional mini. So you can have, maybe nobody's ever taken it, but as soon as somebody does, maybe somebody else does. You can have several different classes, several different bodies, groups of people who have taken that course over different semesters maybe. That's what the mini part is. So the cardinality to me is, I guess it's really 0 to n. This is saying you have 0 up to who knows how many is what the n means. And this means that a particular class will only be in one course. You can't have a class that a group of people will come together to study at the same time and the same teacher and the same assignments and stuff for 2 different courses, like math and physics or something. Though that does actually happen sometimes, but we won't get into that now. So what this symbol means in between, this, first of all, you see it's got a verb. A course generates several classes. I guess that's an okay word. The vertical lines, I think it's kind of confusing because the one vertical line, in my mind, I might not know exactly what this means. You don't really need to, I found, but in my mind there should be one vertical line maybe. I just think of one vertical line's there for show. That just means one. It's the one side of the relationship. The other one means mandatory. So if you have a class, if you're in a class, it must come from some course and only one course. So this means one and only one course, not several courses. It's just one. This class is generated by one course. A course will generate 0 or more classes, but if you have a class, it's generated by one course, and it has to be one course, and it can't be fewer and it can't be more. It can't be 2, it can't be 0, it can't be 3, it can't be 0. It has to be exactly one. That's what this means. This is a common crow's foot picture of a relationship. So if you know this one, this is your basic building block. Yeah, this is, by the way, I'm going to foreshadow something, and we'll talk about it again when it comes around to it. But this is the degree of this relationship is another way to describe the relationship. It's binary, and why it's binary is because there are 2 entities involved. One entity, 2 entity. It's a binary relationship. You've got a line between the two. There are other degrees of relationships. There's unary, and there's ternary, and there's more than that. The main kind you'll see, degree of a relationship, will be binary. So a degree of 2, if you want to call it that. But the thing we were talking about mainly on this one was supposed to be participation. So the participation, it has to do with the mandatory on this side and optional on this side. I hate the way the slides work. Mandatory. Now this is the same thing. This would be like if you find out the business rules that a course doesn't really ever get counted as a course unless there's been at least one class for it. At least one time people came together and studied in a same schedule in a classroom, usually, maybe online because we do online stuff now. But one professor, and it's a semester, and at the end they have a final and grades and they're assigned. That's a class. And the business rules for this one, and this is where you like when you look at these things, it's like on the test, it's like, what are the business rules? Well, we know the business rule of this one has to be this: a course has one or more classes, and a class is generated by one and only one course. Those are the business rules. Those are 2 different rules, but they're kind of 2 rules for one relationship. It's one way you think about it. Each one of these relationships will usually give you 2 business rules. Business rule number 1, a course generates 1 or more classes. Business rule number 2, based on this relationship, a class is generated by precisely 1 course. The mandatory in here is these 2 bars. So that you see this bar here, this means it has to be at least 1 class. If a course doesn't generate a class, then it's not a course. It doesn't exist. There's no row for that course in this table. I hope that makes sense. Okay, degree, I talked about degree already, so I'll go over it in a little bit more detail here. All right, so let me get back to it. There's going to be pictures of this, I'm sure, but I'll have to describe them before you see them, so maybe that'll help. Repetition. Unary relationship. Unary having to do with the number 1, right? Unus in Latin means 1, so there's all kinds of words that come off of that. Unique means 1 and only 1. That's why very unique doesn't make sense, because it's either unique or it's not. So don't say very unique. It's not qualifiable. Or quantifiable. I don't know what the right word is there, but you can't say very unique. It's very unique. No, it's unique, or it's not unique. Anyway, unary relationship is a relationship inside of one entity. And the way this works is a typical example is an employee manages another employee. So the way to think about it is you imagine all the records of the rows inside of the entity. One of those rows will hook up in a relationship to another row in the same table. That's a unary relationship. Binary is the ones that we always see: doctor, patient, movie actor, all that. Ternary would be, my example is that I do a lot is a customer can order a part from a certain vendor. So you need all 3 of those things at once, all 3 of those entities, in order to do the relationship. It's not just that 3 things are connected together. That's not ternary. Because you can do that with more than one relationship. But if it's one relationship that connects 3 things, that's ternary. Recursive is an example of. A recursive relationship is the same as unary. I don't know why there might be a slight subtle difference here that I don't really see. We'll see when we look at it. But recursive means to run back on itself. Literally is what that means. Recursive is a thing that comes up in programming a lot. Fractals are recursive. There's just things that repeat at lower and lower levels. But in this case, it would be employee manages employee. That's recursive. So I'm not sure exactly. We'll see. We'll see how they demonstrate this one, maybe. So here's a unary relationship. It's one I was saying. So one employee manages 0 or more employees, and any particular employee is managed by 0 or 1 employee. So there might be employees who are not managed by other employees in this picture. And why? Because there's a 0 right here. If there were 2 bars here, then the relationship would be that every employee has a manager. But if you think about it, it sort of doesn't make sense, because who's the manager for the manager? The boss, right? Like the owner of the company. Who's his manager? If he's considered an employee, I mean, it buck stops somewhere. So you would have to have the optional, right? Because eventually there'll be an employee who doesn't have a manager. All right. Binary relationship: professor teaches 0 or more classes. A class is taught by one and only one professor. Ternary relationship. So let's see what this one is. So a doctor prescribes a certain drug to a certain patient. A doctor prescribes 0 or more drugs to 0 or more patients. A patient is prescribed a patient is prescribed 0 or more drugs by 0 or more doctors. And then a drug is prescribed by 0 or more doctors to 0 or more patients. So these are all optional. I would say, in my mind, if all of these are 0, then you don't really have a relationship. But the reason why they're here is because you can say, okay, actually, I feel like this should be mandatory, because who's prescribing the drugs if the patient's getting a drug? But I'm going to go with what they've drawn here. So I'm trying to interpret it. And this is where how you, like, if it's asked on a test, what are the business rules you can generate from this? You would say kind of the stuff I've been saying. So, so there would be like, how many here? I still want to say there's probably only 2. Let's see, a doctor prescribe 0 or more drugs. There would be 3. There would be 1 for each entity. It's confusing, actually. Just write them down and see how many you get, I guess. So a doctor prescribes 0 or more drugs to 0 or more patients. A patient is prescribed 0 or more drugs by 0 or more doctors. And a drug is prescribed by 0 or more doctors to 0 or more patients. I think that covers just about everything, actually. That would be enough on a test for me. If you put those what I think I just said 3, I'd be fine with that. But I mean, you could think of some other example. The 0 is confusing. So let's just say a patient might be prescribed. Let's say this patient has a skin condition. One doctor might prescribe a topical steroid and an oral antibiotic to 3 patients who have that skin condition. That's the kind of thing this would show. This patient was prescribed an antibiotic by this doctor and a topical steroid by this doctor. And then by another doctor, they were prescribed an antihistamine, because it was the allergy doctor. So that's 3 drugs that you got involved in this relationship. I'm going to say this probably shouldn't be many, and it shouldn't be 0 right here, but that's not my choice to make. I'm just trying to interpret it. So this is conceptual, and this is the logical here. They're just saying that when it comes time to put this into a database, you would have to probably have this prescription in the middle to tie it all together. This is a bridge table, except it's got 3 things instead of just 2. So a doctor writes 0 more prescriptions. A patient receives 0 or more prescriptions, and a drug is prescribed 0 or more times. So one doctor might prescribe 2 things to one patient, and you would have the foreign keys from each. It gets complex, but again, just to kind of like bring us back, step back for a second. These are all examples of a crow's foot model of an entity relationship diagram, showing the conceptual. They make a difference between conceptual and logical here to me. Logical would be like the step right before you put it in the database, where you create the table. So you'd have to create a prescription table. But these are all at that stage where you're planning how everything, you're drawing a picture of how everything looks after you figure out all the rules. And this is the crow's foot version of doing it. The only thing that's really kind of missing here, the big thing that's missing, are all the attributes that would go inside each one of these. They just kind of left them out for convenience. Okay, recursive relation naturally. So it's naturally such a condition is found within a unary relationship. That's what I was saying. That like if it's unary, it's recursive, so sort of automatically. One common pitfall when working with unity relationships is to confuse participation with referential integrity. I'm not sure what they mean here, but I guess the question could come up like, the thing about referential integrity that would matter is that the role for the employee who's the manager has to exist before you can manage an employee with it as a foreign key. So that's kind of what they're talking about there. So here's some more unary recursive relationships. These are all unary because there's one entity involved in each one. And I guess they're saying, oh, they're all recursive. I guess recursive could also mean they go back and forth between each other. But I mean, obviously one employee could be married to 0 employees or 1, but not 2 because we don't have polygamy is still illegal. And it goes back and forth. This is more of a hierarchical. This is one to many. This is one to one. This is one to many. Remember what I was saying about the one to you just have a line for the one part. So it's optional or one. It's not mandatory or optional. It's one or it's one and optional. So when you just have the one, you usually put a line through it. See, because you have the many here. So this is the one. This is the many. This is the cardinality or the connectivity, and this is the participation. So it's optional here too. You can an employee may not be a manager, or he may manage several employees, and an employee may not have a manager, or if he does, it will only be one manager. And a course has many courses. I don't know what this is supposed to be. What's course? Like a class course and a course catalog? How's the course have many courses? So I'm not sure what it's doing. 0 more course. I don't know what it's saying here. This course is all the way down. You'd have to have an explanation of that one. All right, so used to associative entity. So this is the word I always use. This is where it came from, probably. I hardly ever hear anybody else call this an associative entity, but I like the term, so I use it. An associative entity, you can read these bullet points here, but let me say it to you in a real brief way. An associative entity is an entity that used to be a relationship. So in the Chen model, if you remember, the relationship is the diamond. There's a verb inside of a diamond. That's a relationship. If the thing used to be just a diamond, but now it's a box, it's associative entity. And there is a Chen diagram picture for this, which is to draw the box around the diamond. So whenever you see a box with a diamond in the middle of it, that's an associative entity. And associative entities almost always, enough always to say always, become bridge tables or junction tables, and when you actually go to implement them in database management system. So here's an example. So what you in the Chen diagram, you used to have a many-to-many relationship here. So student enrolls in, might be the verb, enrolls. Student enrolls in many classes. A class is enrolled in by many students. Obviously, a class has more than one student in it, right? And a student obviously takes more than one class, English, math, science, whatever. That's many to many. So before you had the square with enroll in the middle, you had a diamond and a Chen. This is a crow's foot. But if you had a Chen diagram, you would have had a diamond that would say enrolls in is enrolled in by. If you draw a box around that diamond, you've created an associative entity. And then what you do is you've broken the many-to-many relationship into 2 one-to-manys. All right, so I'll let you read this slide. I like talking about the pictures, so let's see what this one's about. Okay, I'm not going to worry about this one either. I'm going to let you look at it, but it's just showing you different ways you could actually implement the tables to do that recursive one-to-one thing. So in this one, you have one table called employee, and it has so it's 2 tables actually. You got a married table and an employee table. I like the first one, but there might be reasons why you'd have to break it down normalization wise. I haven't actually thought about it, so I'd have to think about it. But in this one, you have one employee table. It's got all the employees in it, and then it has a spouse column. Now, here's my thing: in what world are employees only marrying other employees? Right? You're not supposed to do that thing where you eat. If you know what I'm thinking, what I'm talking about, if you know the expression I'm talking about. Why are these employees marrying each other? It doesn't seem very healthy, but anyway. I know at least one faculty member, his wife works at Pelsipi, but I don't think I know her name anyway. So this is just showing different ways you can implement this unary relationship in a database management system. Come back to the slide when you need to do that. I wouldn't worry about it right now. What you want to do is focus on the different degrees, participation, cardinality, connectivity, just knowing what they mean, not worrying so much about how they're going to be implemented at this point. All right. So that's it. That's chapter 4. That was pretty quick. I like talk about that stuff. Let me, before we go any further, before I dismiss you, let's just go through the figures too. So we've seen this figure. A lot of these figures we saw in the course of doing the slides, but if there's anything different in here that might be helpful, I want to look at it. So yeah, they're showing connectivities. Honestly, I called all of this cardinality in my brain, but it's probably good that you know that there's a difference. So connectivity is less specific, I guess is the thing about it. You either have one or many, right? Cardinalities have specific numbers. So cardinality in general, when you hear that term in like a math-ish sort of realm, you're talking about the number of things involved. The cardinality of that set is how many things are in that set, how many items are in that set. That's the cardinality. So we saw some of these slides already. And again, this is the Chen model. Remember I was talking about the diamond in between. If for some reason this relationship were many to many and you drew a box like around it like that, that would create the associative entity. That's the picture I was trying to draw for you in words. I don't know if it helps to do it in a picture actually. As a matter of fact, let me see if I can do this. Okay, I don't want this to be confusing because this is not a many-to-many relationship. Let's just pretend it was. So let's do this. Let's say it is a many-to-many relationship. I'll even change the names here. So forget what this is, but let's say it's movies, movie instead of employee, and actor. All right, so Harrison Ford was in Star Wars, Raiders of the Lost Ark, blah, blah, blah. That's that one actor. And the Star Wars had Carrie Fisher, Harrison Ford, Mark Hamill, Peter Cushing, Alec Guinness. How could I forget him? He's probably the most distinguished. Between him and Peter Cushing, most distinguished actors in that movie. Anthony Daniels, is that his name? Who's R2-D2? I know his name too, and I can't remember it. Anyway. So that's a many-to-many relationship. So it would be acts in, is acted in by would be the verb. So that's a many-to-many relationship before you at the logical model, I guess, if you were right before you implement it in a database, you would have to turn this into an associative entity in your model. And the way you do that is you draw a box around it like that. And that's what an associative entity, this is the symbol for associative entity in a Chen diagram. It's a square with a diamond in it because, again, it used to be acts. It used to be a relationship, but now it's an entity. And then you take these things, and it's no longer many to many. It's one to many, but two of them. So you kind of reverse the direction, and you put the many squeezing the thing in the middle. And each record in this, each row would be a combination of the movie ID and the actor ID, and then you would have maybe a third column that's called role. For example, movie number 1, Star Wars, actor number 1 is Harrison Ford, and then role would be Han Solo. That's an example of how you make a bridge table. It's my favorite one. Actually, that's why I keep bringing it up. So that's that. Now, how do I get out of this? When in doubt, pause and look to how to turn it off. All right, any other slides in here that could be useful? We've talked about a lot of this stuff already. Most of these slides we saw these figures we saw in the slide, but this is another associative entity. I think this is the example from the slide, and I was talking about when I was talking about doing the diamond thing, but this is crow's foot. Crow's foot doesn't have a special thing for it. It just has this in the middle, and they call it enroll. Enrollment to me is a better name because enroll sounds like a verb, so I would call it enrollment, because again, this is an entity now. You've graduated a relationship to an entity. So now it's an associative entity, but it is an entity. So I would call it enrollment to make sure that it's a noun. And you can see the primary key from one side, the primary key from the other, combine them together as foreign key. You take those two foreign keys, combine them into one primary key. PK's here twice, but it really symbolizes that each one of these foreign keys is combined to make a composite one primary key. I'd almost like it better if they did PK once here and then just did like a brace or something, because that one PK is the combination of these two. And then you see you have a third thing. This is like roll. This is Han Solo. But in this case, for a certain class and a certain student taking that class, enrolled in that class, he'll get a certain grade at the end. All right. Okay, so this is a slide we didn't see, so let's see if we can figure out anything about it. You can see how they have the dotted lines. The dotted lines are because they are strong relationships. Wait, hold on. Weak relationships. Dotted lines weaker than a solid line, right? But they're weak relationships because these are all strong entities. See, prof num, school code, debt code. There's no prof num here, no prof num here, no school code like here. So these are all strong entities and they have weak relationships. And this is saying that a professor is the dean of 0. So when I'm a professor, I'm not likely to be the dean. That's the optional. That's the 0 part. But if I am the dean, it'll be one department. So the dean would be the whole thing. So BCT. This is set school. So that'd be the dean of the whole school. So I don't know who's the dean of our school. I know Kathy Bird is the acting dean. Assistant dean. I don't even know who the dean is, unless she is. And then the school operates different departments. So you can have deans for departments here too. So that would be a different line, right? Anyway. Department offers 0 or more courses. So this is a different level, right? The course can have many classes, but you can also, the department offers, maybe they don't have any courses yet. You just created the English department and you haven't designed any courses. Or maybe there's no courses offered this semester. Depends on the business rules, what you mean by that. But I would normally think you'd have to have at least one here, so I would put a mandatory. But again, this is a weak relationship. That's why it's got the dots, the dashed line, because these are both strong entities. Department code's not part of the primary key over here, and CRS code's not part of the primary key over here. So they're strong entities with a weak relationship between the two. They could exist even if offers didn't exist, but probably not in my mind, but you know, you get the idea. And this is just, I mean, these are just more examples, but it's good to see a bunch of examples. And again, if you're doing business rules, the business rules you would say for this one, we just show you another example. Examples help. What are the business rules we can see here? We can see that a semester includes 0 or more classes in it. There are 0 or more classes held in that semester. A course generates 0 or more classes. A class is generated by precisely one course, and a class is included in precisely one semester. For example, you guys will not be continuing this course, this class, right? This class. You won't be continuing database in the fall. It'll end at the end of the semester. That's what it means by is included in exactly one semester here. Those are the business. If you wrote those business rules on a test, the ones I just said, you would get 100. So rewind and play it again. There's no reason for me to repeat this when you can rewind and replay it. But those are the rules. The weak relationship, that's not really a business rule. If you actually knew like precise numbers, like how many courses a semester could have in it or something, you could include those, but they're not here, so you don't need to specify for business rules. This is showing also that you can have more than one relationship between two entities. So in this case, we're saying that a department, and again, these are weak relationships, so these are strong entities, but a department can employ at least one professor is what this means. Mandatory, at least one, but very possibly many professors. So English has a bunch of professors in it, and it has at least one professor, but it probably has a lot. That's how many professors are in the English department. One of those professors will possibly chair the department, but only one. So a professor can chair 0 or 1 departments, and any department will always have a chair. There will always be one. That's the mandatory, and it will only be one. So that's 2 different. This is the employees. This is like, hey, I'm in this department, and this all has to do with chairing the department. Those are 2 different relationships, but it's the same 2 entities, 2 binary degree relationships with different cardinalities and stuff. You could have even more relationships than that, but those are 2 right there. So there's no rule that says you can only have one relationship between any 2 entities. This is another, I don't know why this is here, but I think this is probably a little project because it says the 5th Tiny College ERD segment. So you're like looking at different parts of it as just a practice if you're reading through the chapter. And these are figures from the chapter. That's why I'm showing them. But in this segment, we're seeing that and here's the business rule again, a professor at Tiny College teaches 0 or more classes. A class at Tiny College is taught by precisely 1 professor. Okay, what does this one looks like? This is the enrollment. We've seen this before, but again, I'm not going to go over the business rules. I think we know what they are. But because I think I've said them before, I don't want to repeat myself. But a department, in this case at Tiny College, a department has 0 or more students in it. And a student is in 0 or more departments. Maybe you have to decide on your major before you're considered part of the department. I don't know. Okay, a professor advises 0 or more students. If they're lucky, they have 0, right? But whatever. They might have several students that they advise. And a student is advised by precisely 1 professor. At Tiny College, maybe it's different in Pellissippi. I know sometimes you have advisors that's their job to advise, and they advise you, but also your professors can too. So that might be, we have different business rules, but at Tiny College, a professor has 1 advisor, a professor, and he has to have 1. Look, he can't have 0, right? It says it's mandatory. So that's the business rule. A building contains 0 or more rooms. So what's a building without rooms in it? I don't know. A class and a room is used for 0 or more classes. So maybe it's a maintenance room, so it doesn't have classes in it. So that would be 0 or more. A class uses precisely 1 room, and it has to use 1, and it will only be 1. It can't use 0 rooms. It has to use 1 room. That's what these 2 bars are, 1 and only 1. And a room is in exactly 1 building. A room can't be in 2 buildings at once. It's not like the TARDIS or something. So whatever. And this is like the whole thing. I'm not going to do everything in here. Looks like Tiny College has a lot of parts to it. So if you remember in the next slide, you'll see the thing where I talk about the external views. It depends on what part you're interested in. You might know about. That's kind of what this is. It broke down in 1 big conceptual diagram into little pieces. That's the external. These are like, each one of these could be an external view. And then this is the whole thing, these 2 slides. 3 slides. So I just want to, again, I want to like practice, because people asked about the business rules. I feel like it's a weak thing, so I'm going to harp on it in this. You can cut this off, because the rest of this is going to be business rules and stuff. I'm going to look at diagrams and tell you the business rules. There's only a few more of these slides probably, but this is just for practice. So if you're like, I got it, you can quit. But so a customer owns 0 or more cars. A car is owned by exactly 1 customer. A car gets 0 or more maintenances, so maybe you never take it in because you're a bad car owner, right? But you could take it in like for oil change at least twice a year. So that's the more or more. Maintenance includes, so this is again, the associative entity, the bridge table, because a maintenance can involve many parts, and parts can be included in many maintenances. So that's the many relationship that's been turned into to one-to-many. So think of this as an invoice. So on a particular maintenance, a certain part is involved. Maybe not. You don't need a part for it. You just like tighten up some screws, right? And so no parts were needed. But maybe you would have to order a part that you would use, so like an oil filter or something. So and maybe an oil filter and oil. That's two parts. It's not really a part, but you get the idea. But a maintenance will include at least one maintenance line saying what happened, but it might also have on it the parts that were involved. And so for each line, it could have maintenance number 1 had this part. Maintenance number 1 also had this part. You'll all see that whole two foreign keys that become one primary key in the middle kind of thing over and over again. All right. So these are questions, actually. If you look for the questions and they're asking you what the business rules are, I don't know if that's what it's doing, but I'm telling you the answers here. So a store places 0 or more orders. An order is placed by exactly one store. Store employs 0 or more employees. An employee is employed by precisely one store. An employee, these are all, each one of these little sentences I make is a business rule. An employee has 0 or more dependents. A dependent is dependent on exactly one employee. An order contains at least one, maybe more order lines, and a product is written into 0 or more order lines. So again, this example here, that's the business rule, but the way what this would mean is like, you order something. When you order something, it will produce like a receipt. Is the way to think of this, and there will at least be one line for the order there, and maybe it's just a service you received, like I don't know, information desk. You asked a question, they answered it, and that costs some money. That's an order line. But if they had to also give you a book, like 3 books, so order number 1 would be product number 2, order number 1 would be product number 3, order number 1 would be product number 10. That could generate 3 lines for one order, and then these 3 products would appear, but maybe no products. I don't know why there would be 0. Actually, it doesn't make sense to me. But but order line will always have one order, and order line will always have one product. I know I told you wrong here. Actually, hold on. Let's rewind a little bit. An order line will have always one product and one order on it. What this is saying is that maybe some of the products are never ordered. They're just sitting there lonely on the shelf. So I get confused about this sometimes too. So the product's getting lonely on the shelf and it's never ordered. So, but if it is ordered, it'll be in the order line. So anytime you have an order line, you will always have a product in an order. So order number 1 was for product number 1. Order number 1 also ordered number 2. Order number 3 and number 1 order also ordered product number 3. That's one order, but it's 3 lines in here to show that 3 products were on that order because it's a many-to-many relationship. And then product number 3 was also on order number 2. So that's the one-to-many this way. But product number 7 is ugly and nobody wants it, so it never appears over here. That's why it's optional. An order, though, will have to appear here because if you make an order, obviously you're going to have an order line. You're going to order. If you make an order, you're ordering at least one product. So there will be at least one line here. That's why it's mandatory. But a product may never appear in the order because nobody likes it. I hope that makes sense. I might have mixed that up on some of these other ones. So an employee, that one made sense. A store places 0 or more orders. I guess they could never produce an order, which means none of this other stuff will happen, but whatever. Components of the multi-value. Yeah, I forget all that. We don't care about all this. This is stuff. Oh, this is a handy little chart though to show you the symbols for. This is connectivity for crow's foot, and this is cardinality for like in Chin diagrams. You'll have these. So you can see how this is more well. Actually, this cardinality. I guess cardinality has the symbols instead of this, the crow's foot, and this is connectivity. But this is saying 0 or more. So M means some number. This means 1 or more. This means one and only one. And this means optional, 0 or 1. All right. I think that's it. If you have any questions about any of this stuff, feel free to make an office hour appointment or ask a question in email. I don't know what else to tell you. I got all these figures here. They're going to be throughout the chapter. That's what I just went through, all these. Anything else I need to tell you? Just make sure you study up for the test. And if you have any questions about the things we went over, make sure you let me know about it. This may be, I might use this video in future semesters. So if I do, you may or may not be able to ignore what I'm about to say and some of the other things I've said that are specific to spring 2021. But I haven't made a video for Access Lab 4 yet. So that will be coming for spring 2021. It might have already be out. Who knows? I'm going to make it, so I might just reuse it, right? So it might already be done in fall or spring 2022 or whatever. Or I might remake these videos, who knows? You guys can give me some input. Each time I make the video, it gets a little tighter, but then I like do things like this where it makes it a little longer. So this is something I'm working on. But you guys take care. Good luck on the midterm, which is coming up a week from Friday for spring 2021. It's probably pretty soon for any future semesters too. It shouldn't have happened yet because the stuff's on the midterm, so it couldn't have happened yet, but it should be soon if you're watching this video. All right, take care. Bye-bye.